Okay, Math Bridge 8 students, welcome back. Right here we have the second in 3 videos on the Pythagorean Theorem and the distance formula. And my goal here, this is the most abstract of the videos, but it's fun. I want you to see the connection and be able to explain it for yourselves between the Pythagorean Theorem and the distance formula. To review, in the last video, we looked at just sort of counting up the distance between points A and B. We looked at how to take a situation where we have points C and D and look at the distance between those 2 points by dropping a right triangle and applying the Pythagorean theorem. A very elemental, very powerful concept. Here, we're going to go into this scary place where we're outside of the graph paper. And we wanted to look at any 2 points in space. Any 2 points in space. Here are points F and G. Okay, so how do we do that? Well, one way to think about it, okay, is I don't really know where we are on the XY coordinate plane, but we can pretend that we're somewhere, right? We have to be somewhere here. So I'm going to draw in an arbitrary y-axis. Maybe there. That's the y-axis, we'll just say. And we're going to draw an arbitrary x-axis maybe down here. Now notice that our graph paper still runs out. We don't know exactly where these points are. But we do know that we can locate them someplace on the coordinate plane. And we know that, for instance, that point F, which is, we're just going to think about that as the first point here, right? Has an x coordinate and a y coordinate. x1, y1. I mean, you might glance at it and see that, you know, x1 is maybe about 3 and y1 is maybe, I don't know, hard to look, maybe about 8 up, something like that. But we don't know for sure. We can say, though, it's at a certain amount over x, a certain amount up y. Same thing here. We'll call G the second point, and you know this is at some x, we'll call that x2, and some y, y2. And we want to use the same principle that we used last time in terms of looking at making a right triangle here. So we're going to go down this distance over that distance. That's not quite a perfect right triangle, but it's going to do. Here's my right angle. And we want to know how far that is. So this is here. We can think about that as the vertical distance and we don't have a number for it. We can't just count like we did last time, but we do know that we just subtract. This is going to be y2 minus y1. Yeah? It's whatever, you know, whatever this is minus whatever that is. And frankly, we could go in the other direction too, but you know, we're going to do it this way today. Okay, so now here, by other direction, I mean we can flip the 2's and the 1's in terms of what's the second point and what's the first point. It doesn't matter. We're going to get the same result. Okay, so here is the horizontal distance anyway. Horizontal distance. And I'll flip color here just when I circle things, just so you can see it better. And that's going to be, we don't know exactly what it is, but we do know that like we go from this point here out along the x-axis, x2, back to this point, x1. And so that's going to be x2 minus x1. Okay. So let's go back to the Pythagorean theorem. We have our Pythagorean theorem, which states that a squared plus b squared equals c squared, or more abstractly, or not more abstractly, more concretely really, that the squares of the lengths of the two legs of a right triangle are going to equal the square of the hypotenuse. Okay, so the first thing I'm going to do is I'm going to rename C. Here's my C. I'm going to call it actually D. Doesn't matter, right, what letter we call things. This could be D for distance. I'm going to flip the equation. I'm going to say D squared equals A squared plus B squared. Okay, so my A squared, I'm going to have that be the horizontal distance. It's from here to here, right? And we know that that's x2 minus x1 by the logic that I went through with you earlier. By the same token, the vertical distance is going to be y2 minus y1. So we're going to rewrite this. So we're going to say d squared equals x2 minus x1 squared plus y2 minus y1 squared. And what we want to do now is we're going to find not d squared, but d. Okay? And all we need to do is do the same kind of maneuver we did, we've been doing all along with the Pythagorean theorem. We're going to take the square root of this side, and then this looks scary, but don't worry about it. We're going to take the square root of that side too. The square root of d squared is just d, and we end up with x2 minus x1. Remember, this is just the horizontal distance plus y2 minus y1 squared. And this, ladies and gentlemen, is called the distance formula. But all it is really, and I hope that you can kind of see the logic based on what we did, is a squared plus b squared equals c squared. It is the Pythagorean theorem just in disguise. Okay, so in the next video, we're going to apply both the distance formula and the Pythagorean theorem to find the distance between 2 points. And I think you should be in really good shape with this lesson by that point.